Hello, guys. Okay, so welcome to one and all present here. This is Shakti Sundaramurthy of fourth year BTech Electronics and Instrumentation studying in main campus, and I am very heartily welcoming you all to the 5 day series of workshop, which is under the topic Step into Robotics Basics and Beyond. And from now on, we are going to dive into the world of robotics. So here in the world of robotics, generally we don't discover things. We just think, innovate, create, and then we build it. So here this is. So as we are stepping into this world of robotics and we are going to start this workshop, once again I'm welcoming you all and for this wonderful evening. So let's start the day-wise intro. So that is today, day one. We will be seeing the introduction to robotics and basics. And tomorrow, that is day two, will be the introduction to the components and some basic coding related to it. And the day after tomorrow, that is day three, would be the project demos. It will be basic and related to the day two contents. And the day four would be a new content that would be an intro into computer vision, that is OpenCV. And the fifth day would be deep into computer vision, the advanced version of the day four. So once again, I'm wishing you all the best and have a wonderful evening and a happy learning to one and all present here. So from now on, Karthik Perikarpan would be taking on the session and welcome you, Karthik. Before you start, just give an intro of you and let everyone know you and you can start the content. Oh,
Okay, thank you, Now.
okay.
Hello, guys. Myself, Karthik, from RCS, the Robotics Club of Shastra. So, I hope you are all fine and doing better. So, get ready to be immersed in the field of robotics and try to explore more from now on. So, let us get into the introduction to robotics. Before diving it into the content, let us think about nowadays industries, how they work, how nowadays, industries might use advanced tools and techniques to make the work easier of the human and to produce the quality of the goods in a very good manner so that customer satisfaction will be great. But think about old times. How might they have been produced some good that is of good quality? They might have worked in 2 to 3 shifts with breaks so that the quality of the product will be good, so that the energy of the workers will not be exhausted and will be used in an efficient manner. But they can't continue the same, right? They thought of something. They thought of machines doing the same work they are doing older times. So they thought of manipulators, which is commonly known as industrial robots, which is used to do the repeated works of their industry works with higher precision. So the quality of the products will be higher and the customer satisfaction will be greater than ever before. Ever before. So they introduced the manipulator into their working experience. So as the technology evolves, the definition of robot evolves periodically. Nowadays, you can see some robots like humanoid robot, for example, Sophia, or some cleaning robots, some house cleaning robots or manipulators, industrial manipulators. There are also many types of manipulators. So nowadays, the robotics can be defined as which can sense, think, and act. Sense the environment, sense the changes happening in the environment, and think and the process the changes happened in the environment and act according to it. So, as the technology growth, the definition of robotics also evolve periodically. So, from the introduction to robotics, we can understand that the industrial robot is defined as the number of rigid links connected by joints of different types that are controlled and monitored by computer. You might wonder that what is an industrial robot? They are talking about manipulators. You might be wondering about just see your arm. The manipulator actually works like your arm. This is actually the manipulator. In your arm, you can see the shoulders, elbow, and wrist as the joints, and the other as links. For example, if you want to pick an object from a table, you need to orient your arm in such a way that you need to pick an object, and with your fingers, you will grab the object and you will place it in the desired position. The same likewise, the manipulator works with the help of joints and links. Instead of fingers, it uses a gripper or end effector in the case of manipulator. So in this image, you can see the manipulators are used to assemble car components, paint, weld, and so on. So everything which exists in this world has some limitations or rules to be followed. Even humans have some rules to be followed. So let us dive into the laws of robotics given by Isaac Asimov. Then who is this Isaac Asimov? Does he invent anything like a robot or anything? Why he is giving laws to these robots? You might think a lot like that. But Asimov was a science fiction writer who gave three laws of robotics in his book called I, Robot. He wants to establish a ethical connection between robot and a human, so that he gave the first three laws, which states that the robot should not injure the human, or through inaction should not allow a human to come to harm unless that would violate higher order. I will talk about the higher order law later. So through inaction means the absence of activity or movement. So the second law states that a robot must obey the orders given to it by human beings. And the third law states that the robot must protect its own existence as long as it does not conflict the higher order law. Now, what is this higher order law? We don't know about higher order law. We only know about these three laws. Then later, Asimov realized that there will be something that will be conflicting the first three laws, which is the robot might kill a human without conflicting the first law. For take an example, if robot throws a thing to a human, consider it as a child. So the robot doesn't mean any harm to the child. They think that the child may catch it or deflect it, but the child can't do anything, right? It might kill the simultaneously, but it does not contradict the first law. Asimov later realized these problems, and he even rejected these three laws without the help of the higher order law. Now, higher order law, which is also called the zeroth law, the robot may not injure the humanity or through inaction allow human to harm. Here, humanity takes place in the single human, so that the zeroth law precedes all three laws. So I have told you about some joints and links, right? You might have wondered, oh, what are these joints? How they work? Actually, there are get into clear that there are actually two broad categories of joints. They are revolute joint and prismatic joint. Revolute joint is it does a rotary motion, revolve around axis. It is there is another joint called prismatic joint. It has a linear movement, travel along the axis. And the next cylindrical joint, universal joint, and spherical joint are derived from these two broad categories. Now cylindrical joint. Cylindrical joint enable both rotation and sliding along the axis, which means it involves both prismatic and revolute joint. And universal joint. It is also called cardan joints that facilitates rotation around two non-intersecting axes. So there will be no prismatic joint in the universal joint. Only rotation is available. And in spherical joint, it is also called a ball and socket joint, in which the link can rotate around the x-axis, y-axis, either z-axis. So let us go into some videos to understand about these joints. So this is a revolute joint that rotates about an axis. Prismatic joint travels along an axis. These are basic movements you can see in the manipulator arm. The specific amount of degrees according to the design is also possible. Or you can swirl around the end effector. These are some basic movements of the manipulator. Here in this you can see There are actually two parts connected with the screw. Here the screw acts as the joint. We can revolve around the screw. So it is called revolute joint. It allows only revolution and not translation. Next, you can see the prismatic joint, in which it can travel along x-axis, y-axis, or z-axis. So this is actually prismatic joint. Next, that cylindrical joint. In this, you can see that green color part is actually moving, translating along the axis and rotating about the axis. So it is derived from both prismatic and revolute joint. This is the universal joint which allows only rotation about two non-intersecting axes. Axis 1 is this one and axis 2. And spherical joint. You can understand why it is called as ball and socket. The down white part, you can call it as a socket, and there is a ball, and it can rotate along x, y, and z axis. So we can see some basic representations of these joints. The revolute is represented by R, where the degrees of freedom is 1. Okay, you are saying these joints are available, so this can be used in manipulators. Okay, what are these degrees of freedom? I can't understand. If you think like it, then for revolute joint, only the joint limb can rotate. So there will be 1 degree of freedom. One type of motion is possible in that joint. So there is 1 degree. Degree of freedom is 1. Then for prismatic joint, only translation is allowed along x, either x, either y, either z. So the degrees of freedom is 1. Then helical joint, it is like a screw structure, which can either screw or unscrew. Also, there is only one motion, so the degrees of freedom is again 1. But for cylindrical joint, it is 2, because it allows both revolute joint and translational joint. Then for spherical joint, it rotates about all three axes, right? For x-axis, for y-axis, and for z-axis. So as it rotates about all three axes, the degrees of freedom for the spherical joint is 3. And next one is planar robo. Planar robo, you can see it is actually a planar robo created by prismatic joints. The planar robo can move either both or all in x, y, and z to pick and place the objects. Then we can dive into classification. You can take a screenshot of it because we will use it later. Okay, I will move on to the next one. Next is classification. Many of you thinking that the robots might be classified as underwater vehicles or aerial vehicles or manipulators or mobile robots, and in many aspects then they can be classified. That is based on geometry. They can be either Cartesian or cylindrical or spherical or articulated. Some of the now based on the power source. Power source are actually three types. In older times, they have used hydraulics and pneumatics. In present times, they are using electrical. So based on area of application, it is divided into two types: assembly and non-assembly. Based on kinematic chain, it is actually open or closed loop. Simple, you can understand. Based on method of control, it is servo motor or non-servo or stepper motor. So we can dive into the topic, each and every topic, with the clear examples and some pictures. So this is Cartesian robo, which is PPP. As I told you to take the screenshot of the previous slide, it is actually P means planar. There are actually three prismatic joints. As I showed you already, this is a planar robo that we are also known as Cartesian robo, which can move in all three. Consider this one, the red one as a joint 1, and the green one as a joint 2, and the blue one as a joint 3. And all three joints are prismatic joints. So all will
One
do a
minute,
linear.
1 minute. I think screen is not visible. It seems. Once again, present it.
Yeah, no, now it's visible, I think.
Okay, now it is visible. Okay, fine.
From which it was not visible now? From which slide?
Mm, from I think from classification from previous one. Ah,
Okay.
fine.
Okay.
Okay, go on.
Okay, let's get into the classification. Classification can be classification of robot can be in many types and many aspects. It can be classified. So let's get it into the types and let's get it into the advantages and disadvantages and the application where they're all used. So the first one is Cartesian robo, where three prismatic joints are used and arranged in the orthogonal to each other. What do you mean by orthogonal?
Karthik,
Uh,
uh, like one person, Balaji is asking, can you go through the classification once again?
okay. Through many aspects, we can classify the robo based on configuration. It can be classified as Cartesian robo or cylindrical robo or spherical robo or articulated robo. Based on the power source, it can be divided into three types. Actually, older times they have used hydraulic and pneumatic, but present times they are actually using electrical due to its efficiency. Now, based on area of application, it can be assembled or non-assembly based on kinematic chain. It is actually open robo or a closed robo. If it is open, then it is called a serial robo. If it is closed, then it is called a parallel robo. Then based on method of control, it can be controlled in two manners with servo or without servo. You can take a screenshot of it so you can understand. So I will go into the based on geometry classification. So Cartesian robo. There are three prismatic joints arranged in orthogonal to each other. What do you mean by orthogonal? It is actually perpendicular to each other. Assume the three-dimensional axis x, y, z, z. All are perpendicular to each other, right? Like that.
Karthik, screen is not visible again. Can you once again refresh and then start presenting it?
Is it visible?
Mm,
Is it visible now?
1 minute. Ah, it is visible, Ra. Go on.
Okay. Now, what is the advantage of Cartesian robo? Some of them might have attended internships in large industries. They might have seen train-like structure moving above their head. It is actually a Cartesian robo, which can move either in X, Y, or Z axis. So it is actually used to um, carry heavy loads, heavy missions, and they are highly accurate and speed. They are they are cost effective because they can be placed in the ground. They can be held in the overhead and used like a crane. The usage closely resembles like a crane, but it is used in industry. But it requires a large volume of space to operate. So the application might be it can be used in 3D printing. So some of them might
Karthik
have
bro,
been yes bro.
bro, once you enter into the full screen, the screen is not full, bro. Again, the screen is black.
Like, can we do one thing? Ashwin, can you share the screen and like Karthik can continue it? Okay. Karthik, can you stop presenting?
I see. The next one is cylindrical robo, where two prismatic joints are used and one revolute joint. The prismatic joint is actually traversing along the axis either x, y, or z, and revolute joint to revolve around the axis. According to the design, a robo can rotate around a specific amount of degrees. So the advantages are
Okay,
can
Ashwin, 1 minute. Can you like remove the full screen mode? Like, can you go with it? Zoom a bit and go with this itself. Because like if we zoom out, okay, go with this itself.
okay. So there are two prismatic joints and one revolute joint. The advantages are higher load carrying capacity. Like Cartesian robo, it can also carry higher load and high rigidity to the manipulator, but it occupies the floor space because it acts like a manipulator, not like a crane. And the applications are you can use in forging, unpacking, and precision small assembly. You can assemble components that is smaller and you can't held in a hand. And disadvantages are when rotating, the object might also rotate. So you need to overcome the inertia of the object while carrying it. So let's get it into the spherical robo. Spherical robo is nothing but it has a one prismatic joint and two revolute joints. Prismatic joint traveling around along the axis and a revolute joint is used to rotate about specific degrees. The example is Cara Robota. It is actually a popular robo which came in 2019, I guess. It is a famous robo which is used to do all type of possible activities, precise activities. So the applications of it are assembly, packing, or you can pick and place objects. You can program it, simultaneously program the manipulator and it can work. So the advantages are it can be it has a high speed capabilities and it contains a donut shaped work envelope. You might be wondering what is work envelope. It is just a workspace of a robo. In first slide, you might have seen that there is a workspace for each and every robo in the industry, so that the two works uh, done by the manipulator does not be collided, so that there will be no error in the industry. So for each and every manipulator, the workspace will be provided and nothing will be entering the workspace, even in industries. So another advantage is it can perform a high grade in short stroke and fast assembly. So as it is programmed, it is actually a fast response. But it typically requires dedicated robot controller. As you see in cylindrical robo and Cartesian robo, it does not require a dedicated robo controller. But in Scara robo, you does require a dedicated robo controller. So we will get a picture how it looks like. Now you are seeing that is the Scara robo, which can rotate about some specified amount of degrees according to the design. And the joint 3 can it is the end effector. It can extend or contract. It is actually a prismatic joint. So there is two revolute joint and one prismatic joint, and the degrees of freedom of this robo is 3 because there are two revolute joints and one prismatic joint, so totally 3. The concept of degrees of freedom will be later explained by Ashwin. Now based on articulated anthropomorphic robot, RRR. So in this robo, all the joints are revolute joints and no prismatic joints are used. And it is very difficult to control these types of robots because you need to, for example, if you need to pick something from the table, you need to orient all the joints in such a way that you are in the correct position to pick the object from the table and grab it. If there is any slight mistake in the joint, slight mistake in the degrees of the joint means then you can't, that the error accumulates for so on. But it has a high speed and it has a large working envelope, that is it has a large workspace and great in unique controller, and it can weld and paint easily like all other robots. But for this also there is a disadvantage. You need to have a dedicated robo controller in addition to line master controller. The applications may be similar to Cartesian robo, cylindrical robo, and spherical robo, but this has a higher wide application because as all are revolute joints, more number of possibilities of more works can be done with this articulated robot arm. So let's get into the next topic. Actually, it is based on power source, hydraulic, pneumatic, and electrical drive. You might have seen in car workshops, there will be hydraulic drive to power to lift the car from base to wash it. So hydraulic drive, they are known for the ability to handle large loads. So that's why they are using in the car workshops at a high pressure, making them ideal for applications, such as constructions. But for pneumatic, they are for quick response, but they are not very precisely like hydraulic. They are less precise. They have faster response than hydraulic. Then electrical drive. They actually work based upon the motors and actuator in the manipulator and robo. Now let's get into the difference between hydraulic and pneumatic. So in hydraulic, in a car workshop, you can see there will be some greases in the hydraulic machine. The greases, oil will be spilled off. So actually, in that way, the compression liquid is hydraulic oil, but in pneumatic, air is used as the energy source. Thus, air is used as an energy source in pneumatic. The speed of response is fast because air is not thick. It can be easily compressed, so the speed of response is fast. Whereas oil is a viscous fluid. So when you try to compress it, it will not be compressed like air, but it will be compressed like somewhat lesser efficiency. So speed
Karthik,
of
like one Balaji is asking, what is the source of JCB? I mean, power source of JCB.
GCB.
Hmm. In which category it can be categorized? He's asking. Basically, source.
GCB.
JCB.
JCB.
Ah, yes, yes.
It is actually a manual controlled one. It's actually used electrical drive.
Okay, you go ahead.
Hmm. For degree of precision, the hydraulic will be good. So it is used in car workshops and so on. But for pneumatic, the degree of precision will be bad. As, then complexity of piping system. To for the air, there's nothing but you need to take the air from the environment and use it for your compression and just leave it out of the environment. And you can repeat the process so on. There will be no leakage. There will be no complex piping systems. But in case of hydraulic, the piping system is complex because you need to transport the oil from one tank to another tank to be compressed, and the used oil must be discarded carefully. So operating environment will be clean and safety for pneumatic as it uses air as a compressant for energy source. And if hydraulic uses the hydraulic oil, there will be fire risk because oil might be flammable. Oil will be flammable. So electrical drive will be explained by Ashwin. I would like to hand over this session to Ashwin.
Good evening, everyone. This is Session, and I'm taking on from here.
Ashwin, you're not clear. Bit audible. Bit sounded properly.
Is it audible now?
Ah, yes, yes, it is proper. Introduce once again and go on.
Hi, guys. Good evening, and this is Session. We'll be taking on from here. We have a lot of cool things to explore. Okay, I'm presenting the entire screen. So, okay, there's a thing called kinematic chain. Kinematics is nothing but when something is moving and how it is moving, and the study of it is called kinematics. And in robots, there is two things called serially manipulated and parallelly manipulated. These are some images. The one on your left is a parallel manipulator, and the one on your right is serial manipulator. The main difference between these two is like similar to that of the resistors, how you connect them in a circuit. In a series combination, you will connect the resistors one by one, like the end of one will be facing the start of the other one. And in a parallel circuit, all the ends will be connected and all the starting points will be connected in a line. So we'll see a short demo. This software is called Robotic and it's absolutely not free. You have a 30-day free trial. My trial is going to end too, but we can do some simulations in this. Okay, now we have two types of robots here. The left one is now a serial manipulator, and the right one is parallel manipulator. And there is a concept of degree of freedom which he explained, and that has a lot of things to do with it. And I guess you have not understood that properly yet. Maybe we'll get into it once again. For example, we can take a chess piece and explain. So, for example, I'm playing g5, g3 pawn. Don't play g3
Bro,
pawn.
it
It's very bad.
seems to be the audio is less, bro. Can you speak a bit louder?
This louder is fine. Is it fine?
Yeah, bro. Continue.
Okay. Speaking of degrees of freedom, so what do you think the degree of freedom of the queen is? You can respond in the chat. Can you guess what's the degree of freedom of this queen, white queen here? You see dots over here. Okay, I'm seeing some numbers, all three directions. Okay. Speaking of degrees of freedom, there's another thing you have to remember that is, it's the minimum number of coordinates or parameters required to define its pose or position. So I'll give you another clue. 6 and 9 are not the right answers, nor is 3. Dwarf is not 3. I'm sorry. Okay, remember one more thing. It's the minimum number. So the clue is all of the chess pieces in a 2D chessboard have the same degree of freedom. Can you guess what is that number?
Many are saying three,
Okay,
two.
okay, I got two. I got two. Okay, good one, Tarun. Okay, how is it two? I'll explain. The rows on the chessboard are named from A to H, and the columns from. Okay, it's the opposite. Rows from 1 to 8, and the columns from A to H. Any piece on the chessboard anywhere can be represented in terms of Cartesian space. That is, this queen here is on the square F2, uh, uh, row 2 and column F. This black king is on the square D5. Okay, so the DOF for all the chess pieces in a 2D chessboard is 2. Like any position can be represented in terms of a one column and a row. The intersection will be the position of the piece. Let's come to this simulation here. This on the left is the serially manipulated robot, and one on the right is the parallel manipulator. So degrees of freedom for this one can be seen here. The
Ashwin, 1 minute. Can you change the background color to any other color? Because it is black, na, so parallel manipulator is not properly visible. Is it possible? Or else you can
Yes,
continue.
possible. Okay, I'll finish serial first.
Okay, continue.
So on the right bottom, you can see this thing called joint axis jog. Fancy words, but we'll make it simple. You can see six angles over here. We can control them separately. Each angle represents the amount of rotation of each motor here present inside the robot. One here, you can see the highlighted parts. One on the here, one here, one here, one here, one here, and totally there are six, including this end right here. Okay, and as I vary all this, you can see it turn. Okay, so the degree of freedom for this robot can also be seen on the website. Look, everything has its own degree of freedom. The axis represents the degree of freedom. We can also filter the results based on that. Most of the components work based on the degree of freedom. It's a very basic concept for all the robots working systems. Okay, this serial manipulator has the end effector. This is the end effector. End effector is nothing but the end position or the component which holds the what is to be done. For example, you can place a robotic hand kind of thing here, or a spray paint can that is used to be automatically paint over the area of something. Even that can also be taken on the website, but it will continue with parallel manipulator. As you can see, the serial one has a point kind of thing on the end that also has the axis of for the end effector's position. We'll remove this guy. Okay, the parallel okay, maybe I'll remove the color. Okay, the parallel manipulator has three arms that are like in parallel to each other, meaning all the ends, these ends are connected at the bottom, and these ends are connected to the top. All these are motorized separately, like this one's a motor, and this one's a motor, and this one's a motor. These parallel lines you see here are just the connecting arms. This one's not a specific point, but a platform. Yeah, it can be used to place an object and tilt it in all the three directions. Okay, that's up to serial and parallelly manipulated robots. This one's a detailed information on that. You can take a screenshot if you want. Okay, robots also are classified based on how we control it. Servo and non-servo control. Servo control is nothing but you are motorizing it. You're using electrical programming, computer programming, and electrical devices. And non-servo control is a simplified way, and it also uses only a open loop system. Open and closed loop are another different concept. Open loop is where you don't get feedback of the output. Closed loop is where you get feedback of the output and vary the input parameters according to the output. Okay, speaking of a mobile robot, something which can move like the Tesla, which can automatically drive itself, they can be controlled in two ways: point-to-point
Bro,
control
the
and
screen is
pin.
not visible.
Wow.
Bro, in the meantime, Balakrishna has asked the question: do degree of freedom signifies the working of robot in different coordinates, or it shows how many ways a robot works?
Degree of freedom is more like a limitation of how much space it can reach and the flexibility of it. Okay, That's the thing. Like you can see here, there's this feature where you can. This is the robot's workspace. All the points can be reached by the robot's end position, the end effector or the platform. Degree of freedom affects this area. This is a volume kind of thing here. It's in 3D. If there's a higher degree of freedom, there is a lot of space we can cover. It's just a limitation. Degree of freedom is. It's visible now, right? I don't go.
Yes, no, I think it's visible right.
Okay, mobile robots like automated cars can be classified into two, can be controlled in two ways: continuous path and point-to-point control. In point-to-point control, we define a specific
Ashwin,
set of points.
Ashwin,
Yes,
like when
yes.
you come to the like PPT part, no, that time the screen is not visible.
Canva is doing something. Okay, let it download. Maybe we can facilitate using Microsoft.
Ashwin is done.
It's done, but yeah, it's done.
Okay. Oh my god. Like
I didn't
wait.
enter full screen. Can we continue with this?
But still the screen. Okay, you can continue. Go with good. Go with it. Go with it. Okay, go with this itself.
Okay, all right. A robotic system has a few parts that work together to complete a task. Similar to the human body, these components also are similar. The controller is like the brain, and it can delivers and gets input from all the other components. It has the program, the computer program, which is used to control all the components. And the power unit is nothing but the battery, and sometimes a battery management system is also used to distribute the power to all the other components. Actuator and manipulator linkage are nothing but like your limbs. They are mechanically operated physical things that can move. These are like, if you go back to the slides, you can find it like the ones using
Bro, it is
hydro.
disappearing again, bro.
Oh, what do I do?
Once it is entering into the Canva, it is disappearing.
Hmm? Is it okay now?
Yes, they are saying it's okay.
It goes in between, and we don't know why.
Next time we have to be careful.
Day two will switch to Microsoft. Canvas not
Like
using.
wait. Like again, it's not visible. They're saying Like, what's the possibility?
Or let me just present.
Like, you try presenting it. Like Karthik.
Yes.
Is it okay? Like Aditya, I need confirmation. Is it visible in the live stream?
Just a sec now. It is taking a bit late.
Shall I start?
Yes, I guess you can.
In the live?
Yeah.
Yes, Ravi, it is visible there. Go on with this itself. Go on.
Okay, there are two main types of motors used in robotic systems for the moments. One is stepper and another one is servo. The stepper, by the name, you can tell it can rotate in steps. Like, for example, you can split it into like four quadrants. You can first it stops at 0 and then goes to 90 and then 180, 270 and back to 360. This can be precisely controlled in a servo motor. Sorry, stepper motor. Go back to stepper. Yeah, construction is simple. You have two different phase, that is nothing but an electromagnet. By repeated and alternative energization of these two phases, the center part that is connected to the shaft, which is also a magnet, that is a permanent magnet, unlike the coil windings, which are electromagnets. These permanent magnets align itself to the phases that energize, which produces a separate north and south poles. By this, the in the right diagram, you can observe small teeth in the coil windings and in also in the shaft. These teeth are used to precisely align the magnets and precisely control the amount of rotation. These motors also require a separate circuit called a motor driver, which a servo does not require, and it's also easy to interface with other components. Let's go to servo. So servos are also can be precisely controlled in terms of position, velocity, and torque. Uh, this have a inbuilt circuit, which is a motor driver. Uh, to this, we can supply three types of signals. The two will be your usual negative and positive terminals, and the other will be the PWM signal. PWM is called a pulse width modulation signal. This is a signal type used in robotics and other things also. Uh, this represents the width of the pulse. Pulse is nothing but a short spike in voltage with respect to time. The number of pulses and the width of pulses determine the position and rotation and the speed of the servo. This is the construction. You can see there's a bunch of gears inbuilt into the servo. There's a separate DC motor in the servo, which is the main controlling unit, and the bunch of gears are used to higher torque than the DC motor. This works on a closed loop system, meaning that the speed, velocity, these information are se- sensed by some sensors that are called as encoders. These information is provided back to the input, and based on that, precise velocity ratios can be obtained. Okay, sensors and transducers. Again, fancy words. But sensors are simple. You may have heard this word many often in the first year. Sensors is nothing but these things can measure a physical variable that we cannot control. For example, distance between two objects. An ultrasonic sensor is placed and in a circuit, and it can measure the distance between it itself and another object in front of it. PIR sensor can be used for motion detection. Load cell can be used for weight detection. These all the sensors require a controller to provide the output. Cannot work alone. Okay, we can proceed. Transducer, it's like the opposite of sensor. It creates a physical variable. Like for example, sonogram, which is used in what do you call that when someone's pregnant and you visualize it using a sonar transducer, meaning you send a continuous sound waves inside the womb and it reflects back from the baby and you can visualize it in a computer. That's called a transducer. It gets an electrical signal, converts it into a physical variable like sound, light, etc. In a robotic system, in recent days, robotic vision has also been developed, which is like our eyes. Robots can now see and talk. Uh, a vision system comprises mainly of a camera, and that camera is not enough. It can see through the camera, but it cannot understand what is in front of it. Uh, very detailed and programming related things are used to convert that image, analyze that image, and feed it to the AI or whatever that is used. And this is called pre-processing the data, and it's given to the controller, and the controller does some programming and other calculations, and the output is got by us.
Anna,
Yes.
once you zoom the page so that it will be visible to the viewers. They are saying that it's very small so that they can't visible.
We'll also try to share the material. Maybe it'll be useful.
It's enough lah.
Okay, this is like a mind map. It consists of a camera, a digital computer, hardware, and software. What the flow is nothing but first it gathers the image from the camera and it goes through the processing and analyzing of the image, and then based on the calculations done by the controller, we get the output. There is a separate and very detailed programming related tutorials on the coming days. We can proceed with the Q&A session as Canva has let us down today. We ran fast today because it's just a 1 hour session. If you want me to repeat anything, me or Karthik, we can say it in the chat.
If there's any other slide you want to review again, we can show you guys.
Bro, I think they are asking the manipulator part and a little summary of what we have discussed today.
This is about the joints and all.
I guess the manipulators, yes. The PPR, the classifications, I guess, if I'm not wrong. The classifications, not this one. In the next one. Next one. Based on configuration. Ah, yes. These kinds, I guess.
Okay. Now, this is actually there are many types of robots which can be classified in many aspects. To the basis of the geometry, we can classify it as a Cartesian robo or spherical robo or articulated robo. Where Cartesian robo, it has three prismatic joints and it is represented as PPP, like PPP shortly, and they are arranged in orthogonal to each other. Orthogonal means perpendicular to each other. So the some advantages are it can carry heavy load so that it can transpose many machineries from a specific position to the desired position, or it uses a simple robot master control. You can easily control it with a remote control, like you control your remote car, and it
Uh,
has only simple operating.
Karthikana,
Ah,
can you just minimize the extra slides down there
okay.
and zoom the.
Now, as it used to carry heavy load in industries, you can use it in the industry, but it does not require the floor space. It requires the space above us. Actually, some of them might have attended internships in industries. So you might have noticed there is a crane-like structure above our heads, which used to carry the machineries and packages inside the industry. So they you will use the Cartesian robot to carry all these. But the only disadvantage is that they require a large volume of space to operate. So only they are held up above heads like a crane structure. The applications are 3D printing, like a pick and place the machines, and some CNCs and sealing. In 3D printing, you might have noticed that the printers will print in a serial way, like all the moves will be in a prismatic way along the axis. Not there will be nothing to rotate in it. So in 3D printers, the Cartesian robot will be used. So cylindrical robo. In cylindrical robo, it can be also represented as PPR. Two prismatic and one revolute joint is used. Then application might be for forging as it is using the revolute joint. We can use it in forging applications and packing and machine tool loading. For in lathe machines, you want to load the machines with different types of tools to uh, carve the steel body parts. So for that, you can use cylindrical robo for the machine tool loading. Then for advantages, it is highly rigid to the manipulator and it requires the floor space. So it also need to overcome the inertia of the object. While it is using the revolute joint, the object might also rotate. There is a possibility it can also rotate and it can be misplaced in somewhere than the desired location. So the inertia of the object must be overcome while using the revolute joint in some applications. So the next one will be spherical robo, which uses one prismatic joint and two revolute joints. The example of a spherical robo is a SCARA robot arm. In this, we can see from the diagram, the joint one is a revolute joint. It can sway around the base about 360 degrees. In this, joint two is also a revolute joint which can revolve around the z-axis with a specific number of degrees according to each and every manipulator's design. And joint 3 will be the translation motion, that is prismatic joint. It can the manipulator can extend its end effector or contract its end effector when needed. So the advantage will be high speed capabilities and you can use in fast operations. It contains a donut shaped work envelope. What is meant by work envelope? It is like a workspace of every manipulator. You might have noticed that manipulators have some cells which they have to compulsorily work on. Like in this, you can see there are steel cages in which the manipulators have been caged up so that no other two manipulators can be collided and there will be no error in the industry. So the operations will be clean and crystal clear. So next, but disadvantages, you need a dedicated robo controller for specifically for to control the
Bro, Karthik bro, the PPT is gone.
PPT stuck.
It's not visible.
Can you is it visible now?
Yeah, bro. You can.
So next will be the articulated robo, which is RRR. Three revolute joints are used, and they are explained in a polar coordinate system. They closely resemble to a human arm. As I said earlier, consider your shoulder, elbow, and wrist as the revolute joint. There are three revolutes, and you can represent it as RRR. With the help of those joints, you can orient in your arm in different position and direction, so that you can pick up object from a place and place it in a desired location, or else you can do lift a object, or you can do the desired actions you need with the help of joints and limbs. So according to the diagram, we can see that the joint 1 can swell around the base, and joint 2 can rotate about specific amount of degrees. Whether can it be one lesser than 180-degree, because as it is attached to the base, some robo might swell greater than 180-degree. It is according to the design of the robo. And joint 2 can rotate about an axis, and like joint 3 and rotate about an axis. As all are rotary joints, the control will be difficult. It will be difficult to control. Now consider the example that you need to set the joint 1 as an angle of 30 degrees, and joint 2 as 50 degrees, and joint 3 as 80 degrees. But you need to continue this position for a long amount of time, and without any errors. And you need to set into different positions so that you can pick a object from the same place and place it in a different one.
Bro, I think your PPT is not visible for today.
Karthik, just wait 1 minute. Aditya, Aditya, can you just post the meet link in the YouTube like chat, and ask whoever has the doubt can join the meet, and we'll explain them here and stop the live streaming. Yes, and ask them to join the meet here if they are having doubt.
No, I think you can pin that link in the chat box.
Guys, whoever has doubt, like, come on, one by one, you can ask the question. Our respective people will answer your doubts. Or like even if you don't feel to unmute, you can even put it the message here, like in the chat, the Gmeet. Am I clear?
ஆ ப்ரோ சென்சார் அண்ட் டிரான்ஸ்டியூசர் டிஃபரன்ஸ் மட்டும் என்னோட சொல்றீங்களா?
Ashwin, like who? Uh, Ashwin is here, right?
Ashwin left the meet. I think there is a network error.
Okay, you can continue, right? Go ahead with it. Sensors and transducer part. Like, Balaji, can you be precise in what part you are having a doubt? Like in sensor also, like what didn't you understand?
Like, what's the difference? I mean, uh, up until now, like, I know like every sensor has a transducer, but still, like, what's the difference between both?
Okay, sensor and transducer. There's a small difference only. Like all transducers are having a sensor, but not all sensors are a transducer. Basically, a sensor is a thing which detects the physical thing directly